Good morning, folks. My name is Grover Browning with the GlobalNOC. I've been here for 21, 22 years, something like that. And I'm helping to lead our network automation efforts here in the GlobalNOC. I'm going to start with an overview today of what we're doing and talk a little bit about progress and next steps and how we can get this network automation into your networks. So in particular, if we're not working with you on network automation today, and after you hear what we say, you're interested in it, please let Corey know, and we'll start working with you and get you moving down this path also. So our goals for the network automation program within the GlobalNOC is to present more accurate configurations of the various devices. I'm going to use the word routers a lot, but this is relevant to routers, switches, power controllers, anything that can be configured, particularly if it's configured via a text file, firewalls, any of those devices we can manage through these techniques. And the ability to have an accurate configuration on these devices, a configuration that matches the intent of what or how we want to manage them, is really one of the primary drivers of this. We all know that sometimes corners get cut or configurations drift on network devices. Someone copies a configuration from another device when a new device is turned up, and because of that, inconsistencies are introduced into the configuration. That inevitably leads to incidents, either during the day or at night, some of them service impacting incidents. And so if we can make the configurations more accurate and make them match what your intent is for the network device, we should reduce the number of incidents and align the configs to the actual intended policy that we're trying to enforce with them. We're also looking as a secondary effort to reduce the effort involved in managing the devices. It should be obvious that reducing the number of incidents should reduce the amount of effort we place into managing the network. This also allows us, though, to more easily manage pushing configurations out to devices. If you have several hundred switches on campus, let's say closet switches, or you're managing many tens of customer premises equipment, this allows us to push new policy out to those devices in a much more efficient manner than it would have in the past. Instead of manually logging onto the devices and typing the commands, perhaps during a change management window, we can now schedule a change to push and report back on its progress, or have an engineer drive that push sometime during the day or during a change management window. This also allows for greatly enhanced security auditing. And I'm going to use security auditing as an example here of things we wish we could do, but we don't believe we have enough time to do. The amount of manual effort involved in, let's say, reviewing a 200-line access list on each of 50 devices is rather substantial. It's perhaps something that we know we should be doing more often on a routine basis, and yet the effort involved means that we don't do it quite as often as we should. But with these techniques of network automation, we can turn what would have been a 6 weeks project into a 3-hour project in order to pull all of the ACLs and compare them to each other. And this is built into our network automation tools. So while security auditing is a good example of this, it's also generally any task that we think we would like to do, but takes too much effort to do manually. So uplifts in that area. We also now have the ability to enable a stronger workflow within our networking tasks. So for example, when you reboot a router, because you're upgrading code, you might want to see how many customer connections are up before you do the reboot, and then check that number again after the reboot to ensure that everything's restored to normal. And there's many sorts of pre and post checklists for many maintenance tasks. And again, sometimes corners get cut, or at 3 a.m., a blurry-eyed engineer misses a number and skips over something that perhaps shouldn't have been skipped over. And this allows us not to enforce those workflows, but to present those workflows in an automated method such that the engineer is enabled in the work they do. All of the drudgery in trying to remember the workflow is already handled through the automation effort. The engineer's job at that point is simply to review it and ensure that, yes, this meets the standards and the criteria we've established for this maintenance. This also allows us to perform sort of, I call it cookie cutter configurations. We know that, for example, when we add a new customer, that new customer should be configured with these 12 lines of code, we'll say. And yet a lot of this tends to be tribal knowledge. Things slip by. You ask the person next to you, how do you configure this service? They tell you perhaps a line gets dropped or a special circumstance gets dropped. This allows us now to configure each service in exactly the same way, and yet still gives us flexibility to handle those exception cases that are so important in our R&E environment. And then finally, we have a substantial community outreach portion to this program. We are out trying to give talks about it. That's been delayed here recently. But we've done several last year. We have several that will pick back up again in the fall, hopefully. We're looking into doing virtual conferences as well. So we're trying to take the community knowledge that we have and push that back out to the community in order to make things better for the community as a whole. And finally, sort of a little more grounded here, our goal with the program is to automate about 80% of the most common edits to the configurations and the most common tasks that we do. So this 80% goal is the number of changes that an engineer makes on a device. We'd like about 80% of those to be automated. This allows for corner cases and instances of configurations that are perhaps too tough to automate, at least in the beginning of the program, and yet gets us into this common edits, common tasks scenario that we'd like to reduce some effort, make things easier for folks. So our building blocks for the program leverage GitHub and Ansible, two industry standard programs. GitHub is used to store configurations and other device files. Ansible is then used to push those out to the network. Two very common tasks. GitHub is a leader in its version control. Ansible is one of the leaders in network automation. So we're leveraging that. What we do have is a very small helper app called NAT, which automates, I shouldn't say automate, simplifies the process of using the command line for the engineers. So it presents them with a GUI front end to push configurations out. Select the configuration, select which device you want to push it to, and the NAT application does that for you in the background. Otherwise, though, we're really using two industry standard programs here and not really doing all that much that's special. What we're doing is in how we're tying them together. So we have two systems under development. The first system is concerned with the parts of the configuration, device configuration, that should be about the same on every device. These would be the network logins, NTP protocols, so on, SNMP perhaps. That generally represents about 45% of a typical device's configuration. The second part of the program concentrates on the part of the configurations that should be different everywhere. These would be the interface configurations, MPLS circuits, VLANs, customer-specific configurations, the parts of the configuration that are there for the router to support. This represents essentially the rest of the configuration, about 55% of it. This second part builds on the tooling of the first part. So I'm going to talk about the first part, and then I'm going to talk about the second part, and just understand that the second part builds on what the foundational work that we're doing with Ansible and GitHub in this sort of first system. So part one, this is the part of the configurations that are supposed to be about the same on every device. And I say about the same, you know, we have loopback addresses that are different. We have a host name that is different. Perhaps we have some passwords that are different on each device. We can handle this sort of very gross localization of a device. It's really when we come to interfaces and so on, where we have many instances of something that should be different, that we start to look at this, the second half of our program. So the basic workflow is that an engineer goes to GitHub using a web browser GUI, selects a text file that represents the configuration, and the configuration looks like any other node configuration, router configuration. They edit that text file using the exact same language they would to configure the device, and then they deploy it via a button push. The backend system then localizes that config. So it sticks in its host name, it puts in its loopback address, and then pushes it out to the nodes that the engineer selected. So that's sort of the basic workflow involved here. This is an example of a particular device config. This is what it looks like through the GUI. This is a Juniper configuration for a device. This represents the system config. And you can tell this looks like a Juniper configuration. There's nothing special going on here. It's as if we simply took the configuration off of the device and put it here. There is one line here, oh, that looks a little different. And it's right here in the middle of the screen, node management address. This is pulling this device's loopback address from the GlobalNOC database and inserting it in as the NAS IP address for the device. And this is how we localize this configuration. It's really quite simple. So I'm going to run off now. This is our configuration file. The engineer has gone on through the web GUI. They've edited it. They've made a change. And now they want to push that change out into the network. So I am going to share a different screen here.
You got a quick question from Lonnie here, Grover, while you're doing
Sure.
that. He asked, would you have a automation for dummies baby steps tutorial?
Yeah, I don't think we have one yet, but Lonnie, we are in the process of spinning up a class, a network automation class that was supposed to be here in May. It hasn't happened, but we are trying to reschedule it for later in the year. That's probably our best opportunity. I'll check and see if we have some pre-recorded information from an earlier workshop as well that we can share out with you.
Grover, I'll volunteer to write that as long as I can write it in first person.
Perfect. Yes, please do that. Okay. So I want to show you this sort of small helper app that we have. So the engineer has gone on. They've edited a text file. They come to this small helper app. They choose their network. We're going to say that this is the iLight network. They choose the branch because this is GitHub. We have version controls and branch. In this case, we're going to say it's Grover Demo 2. And then we go down to an action. Our actions are divided into two steps here. The first one is to take the proposed change and send it to the network and do a diff against the actual running config on the devices. So this takes the change the network engineer is interested in pushing out, goes out to the network and says, hey, if I typed this on the device, what would the impact be? And then the device responds and tells us. This is a double check by the engineers, just to ensure that the change that they're about to push out matches what their expectations are. I'll show you an example of that here in a moment. The second step is to actually push the change out to the network and make it live. And again, right before we do that network push, right before we make that change live, we ask the network device once again to do a diff on it, to tell us what would change, and then that's presented to the engineer again. Again, just as a step to ensure that the network engineer, as the expert in the system, is doing exactly what they intend with regard to the change. We can select some target devices. So we can send a change out to every device on a network. We can send it out to a small subset of devices on the network if your maintenance is just the northern part of your network, just the southern part of the network, just one device to try a configuration with. And we have a description field. The description field will allow us, whatever we put in here, to both, let's see, how do I say this? When we do a commit, for example, on a Juniper, we can add a comment to that config commit. So whatever we type in here will be pushed out into that comment. If we were to then look on the Juniper and say, hey, what were the last 15 changes made? We would see an annotated commentary of what the change involved. In addition, the description here can be pushed out to a ticket in a ticketing system. So for example, if we have a change management ticket, during this network push, we can go update the ticket. Now this can be optional or this can be required. There's a substantial amount of flexibility here. So if you wanted to make every change be required to have a comment, we can support that.
Hey Grover, we got another question for you.
Yeah, absolutely.
Adam Nimothy wants to know, how does the target device break down? Is it roles or is it something you need configured in the DB to group devices?
So by default, when we set up a project for you, we determine which nodes in your network this project is related to. So we could have a project that has every node in your network. We could have another project that has just your switches in it or just your East Coast switches. So there's a substantial amount of flexibility here. We can pull these devices on the fly from the database, or we can set this up as kind of a static sort of list or a static list that's updated once a week. So really, Adam, it depends on what your goals are, how you would like to group these. They can be everything. They can be a subset of them. We have both of those options, or all of those options.
Thanks.
Sure. So if I switch over here, we can see what the results of this push out to the network is. And again, this is showing us the diff that the device sends back to us. The devices here, these are iLight devices, are telling me that if I were to send this change out to the network, the lines in green are new lines that would be added to the node's configuration, the router configuration. The lines in red are the lines that would be removed from the configuration. The engineer is looking at this and ensuring that this matches their expectations with the change. If they suddenly see the entire router config disappear, or they see unexpected changes here, they're the experts of the system. They know what it should be doing and what it shouldn't be doing. I don't want that screen. My Zoom controls are at the top of the screen, exactly where my browser bar is. Here's another example of a push out to the network. Again, this is for a different change that I ran earlier this morning. If I were to push this out to the network, what I would get is an an additional line in the RFC 1918 prefix list. This was a fake example I created this morning. So this is telling me the difference between my proposed change and the change that's actually, and the running config that's on the device, routers in this case. Any questions before I move on? Okay, let's go back to sharing again. Okay. So we have available to us in this the full power of GitHub and Ansible. While we have this small helper application, NAT, NAT is meant to be used as sort of a day-to-day workflow enabler. It handles the most common tasks that an engineer would likely want to do and makes it easier for them to work through the command line of GitHub and Ansible by hiding those command lines. But in the background, we do have the full power of GitHub and Ansible. So if there are special circumstances involved or a special project, we have all of that power available and can use the command lines to continue helping to resolve those situations. The system is very flexible. If an engineer needs to make a change right now in the middle of the night to resolve an incident, they can make that change directly on the router, the device node, and the automation system will then pick that up. It will flag that the running state of the network is different from the automated intended state of the network, and will then raise an alarm and say, hey, somebody needs to resolve this. So it doesn't automatically override it. It simply says, something is out of sync. Did you know about that? Someone needs to resolve it. Again, our goal here is the engineer is in control. This is here to assist them, to help them follow workflow, to create more accurate configs, not to enforce standards upon them that they have to comply with. We have individual node exceptions. So if all of the nodes need to be configured a certain way for logins, for example, except for this one special node, that one needs to be different. We have many ways to handle these sorts of exceptions. You can just configure that router differently. It doesn't necessarily have to be exactly the same as all the other devices. We have ways to handle that. We have a special node override text file for each node. Any configuration put in that file will override the sort of standard automated configuration baseline. We have the support for if statements because we're using Jinja 2 here in the Ansible system. We can use if statements. Again, this is all oriented around keeping the engineer in control of the configurations, helping provide guidance, helping with workflow, helping with the drudgery tasks, those tasks that folks know they should do but kind of skip over. This is meant to help with that. Oh, we just looked at the diffs. So we can talk a little bit about progress report. About half of the GlobalNOC's customers that use their tier 3 service have this complete for the core devices in their networks. They are now moving on to their ancillary devices, support switches, support out-of-band routers, these sorts of things. Those configurations tend to be much simpler, and progress in converting them over is therefore much faster. About 45% of their core node configurations have now been automated, and this goes for all of them. The percentages so far have been about the same. And this represents about 200,000 lines of network device configuration that are now guaranteed to be the same and will alarm if the configuration drifts. So an alarm will be raised if the configuration drifts. This is something that is a substantial accomplishment here. I don't believe in the past we've ever had this capability to know with confidence that our configurations are in fact exactly what we intend, with therefore the reduction in incidents and so on. Our next steps for this phase of the project is to work with the rest of the Tier 3 network customers to complete the configurations for their devices and continue to transition the ancillary devices in the networks that have already completed their core configuration. We do have some stretch goals with the program. This would be additional workflow enhancements to really think hard about what pre and post change auditing, alarming, or commands that we want to run for each change on the network, and configuration reuse. If all of our devices that are configured, switches, routers, firewalls, whatever, if they're all supposed to have about the same login users, for example, or about the same NTP configuration, or about the same ACLs configured, we'd like to get our networks into doing more configuration reuse. So instead of having 3 configurations, we have, for example, 1 configuration, in those cases in which it's appropriate. Do I see a question? No. Okay.
Yeah, there was a question. It's from Dave Morrow. Grover, what's a core node in the context of this talk?
Oh, so that's a good question. So by core node, this is really just a grouping of the individual networks. So sort of, I think in your example, Dave, this might be, well, I should say that. When I say core nodes, I think I mean the most important network devices for these customers. So in the case of Internet 2, it might be their backbone routers. In the case of the Indiana Gigapop and iLight, it's their backbone routers rather than their CPE devices. But it's really, when I say that, I mean, when I say core node, I mean the most important devices to them to keep consistent.
Sal Ghani, and I'm sorry if I mispronounced your name there, from Learn, was asking, do you support servers from bare metal to deployment?
Yeah, we sure do. Not only servers, but networking devices as well. So if you're churning out, let's say, 3 new CPE environments a week, or you're churning out 5 new servers a week, we can create a baseline config, because that's what we're doing with this. We're creating a baseline config for these nodes. So we create a baseline config. We enter it into the database with, let's say, a host name and an IP address for it. And then it will automatically crank out the baseline config for that device that we can then push onto the device. And it's guaranteed to be accurate. No longer are you, well, by guaranteed to be accurate, I mean matches the baseline that's been defined. But no longer are we copying configurations from another device. So yeah, absolutely, we can do that.
And for servers, we typically use a complementary set of tools to this that includes Cobbler and Cone and Puppet, but it's integrated with this stuff as well. I'm happy to go into more details with you guys on that at some point.
Sure. Okay. So I want to talk a little bit also about the lessons we've learned here. Because we're using industry standard tools, the effort with our network automation project has not been with the tooling or in development. It's really been in the development of these baselines, in trying to figure out for a specific network device, what is the correct configuration for that device? If you have 50 routers, there are almost certainly 51 different versions of a baseline configuration, what you think it should be, and then the 50 actual examples of what's being run in the network. And the ability to examine what you actually have running in the network and determine what is accurate, what should the configuration actually be, is generally where the effort here is. This involves trying to understand why you did a special configuration for this one customer. Is that special configuration still relevant or is it not relevant? And so on. This sort of analysis of what your current running configuration is tends to be where the effort is, not in the tooling itself. Okay, I'm going to take, I've now finished on the first part of the system. I'm now going to talk a little bit about operational automation. But any questions before I move on to this? Okay, so operational automation, this doesn't fall into one of those two buckets. Those two buckets that I talked about in the beginning are really related to configuring network devices. Operational automation, though, is more related to, I want to run a specific command on every node. And I think about it as I'm typing a show command instead of a configuration command. So for example, you might want to see how full the file system is on each device right before you do a code load on it to see if you have enough room to put the new code on it. You might want to see which switches in your network are configured in stack mode. These sorts of commands or these situations, use cases where you want to run what is essentially a show command on every node in the network. And our GitHub Ansible foundation allows us to do this as well. I don't really talk about this much, but we have this sort of capability also for troubleshooting and analysis. And it's really just as simple as it is to configure the network. We simply define a command, it goes out and runs that command on every device, and then gathers it all together and shows it to the engineer in one unified screen, which makes it much easier to analyze the results. Okay, so we're going to cover part 2 now. This is our new ground. This relates to the parts of the network devices that are supposed to be different. And this really gets to the idea of services. What does it mean when a customer is connected to your network? What does it mean when you configure a VPN tunnel? And I say here, right, well, what it means is that I ask the person next to me and I copy the last configuration. What I'm talking about here is trying to understand the actual services that we offer on our networks. Trying to understand what those use cases are, trying to understand what the configurations are for that, what information we need, so that we can then try to create a cookie cutter mold specific to that particular service so that we can stamp those out in an automated fashion. So this sort of idea of understanding what services you offer to your various customers and why a particular customer doesn't match that model. Why is their configuration different from all the other customers? Again, this is where the effort is in this, defining what your services are and trying to understand why you have exceptions and if those exceptions are still relevant. Just as with the first part of the system, this is where the effort is in this particular system. We're using 2 building blocks again. We're using Yang and OpenConfig. Yang is a structured language, much in the way that XML or HTML is. It allows us to build GUIs, define which fields are important. So if I'm configuring a VPN service, maybe I need a pre-shared key. Yang helps us define that we need a pre-shared key. And then we're using OpenConfig as well. OpenConfig is a vendor-neutral configuration language. You can actually today go onto a Juniper router and use OpenConfig, typing it at the command line to configure a device. Cisco has support for it, particularly in XR, and other vendors are moving in this direction as well. So we are storing our data in OpenConfig, and we are storing our cookie cutter molds in Yang. Yang helps us define what's required for a service, and then we actually store that required data in the vendor-neutral OpenConfig format. And then we leverage the GitHub Ansible environment for version control and, again, to push it out onto the network. So what we're talking about here are really services. And when I say services, I mean it's the parts of the config that are different. And they're different because they are in support of something. They're in support of a backbone interface that connects two nodes. They're in support of a connection to a customer site. They're in support of an MPLS connection for a site or a VLAN or something of that nature. And we're going to call that something here a service. When we talk about services and we talk about network configurations, particularly for new devices, when we add, for example, a new customer or an MPLS circuit or a VPN tunnel, we're touching many different parts of the config. So we tend to think of it as, I need to configure my interface, I need to configure a firewall, I need to configure an ACL policy, I need to configure a new routing instance, something along those lines. But we're trying to flip that model here and look at it from a different axis. Instead of looking at it as, we need these three things, these three different parts of the configuration configured to support the new customer. What we're trying to instead say is, to support a new service of type VPN tunnel for this customer, this is the configuration model that is used. Let's see. So this is an example of that. This is an example of a configuration, a dummy configuration for a VPN service on the Indiana Gigapop. And you can see here, we have a grouping with a name. You can think of this as a service name in the GlobalNOC database, intent VPN service 1501. And then gathered under this grouping, under this name label, is all of the configuration related to this particular service, the interface configuration, the routing instance configuration, the IKE policy. All of that is bundled together in one small self-contained package. So when you're troubleshooting the configuration for this service, all of the config is right here bundled together. So let's go look at a VPN example. So to start the example, I want to show sort of how you get into this configuration screen. What I'm looking at here is the GlobalNOC database, and I'm looking at one of their customers, the Indianapolis Zoo. And if I scroll down far enough, I will see a small section called Services. Now imagine that when I clicked the Add New button here, a screen popped up and let me pick a service of type VPN or customer VPN or something along those lines. This is the front end into this service configuration tool. It is the database, it is the customer. If the service already existed, it would be listed in the services section, and there would be an edit button that then let us go edit the service for that customer. So when I add that new service or I edit that service, I get our intent tool popping up. What you're going to see on the left side of this is the results of the Yang file. This is the cookie cutter mold being displayed interactively to the engineer. What you're going to see on the right side is the actual network configuration that will be pushed out to the device. So we show the engineer exactly, based on the choices they make on the left side, exactly what the configuration will be that is pushed out to the device. So I'm looking at a service. I can see a service name here in the upper left-hand corner. I can define that this service needs to exist on router.something. You can see that it's helping me with autocomplete here. So it has a text box that is helping autocomplete. I can pick a specific node. And you can see over on the right-hand side, as I picked this node, the dialog box in the upper right-hand corner for View Config for Node updated itself. I can choose an entity. Let's say this is for ING. And I can choose a subinterface unit. So we'll say this is subinterface 45. The pre-shared key, the security key, we're going to say is Grover key. And we can add some IP addresses here. And in particular, as I'm editing this device, this IP address, note how it is updating the configuration on the right-hand side of the screen. So again, exactly what I tell the device, this is what the configuration will be based on that. So 1.9, 2.1, and 68.6.5. So again, the Yang model that defines a VPN service tells me, or defines that for this particular service, for service of type VPN tunnel, I need to know the name of the router it wants to be configured on, the entity it's being configured for, the subinterface unit, the pre-shared key, and then 4 IP addresses. Every time I configure a service of type VPN, I need those pieces of information. It's exactly what I need. And then on the right-hand side, as I've typed that in, it's showing me exactly what the configuration that will be pushed to the device is. Now let's say there's an exception here, right? Let's say that the MTU is not 1400 for this particular VPN tunnel. I have the ability to override that. I can click a button and it will show me all of the options available, and I can change my MTU to, I don't know, 1800's a nonsensical value, so let's use that. And then it updates it on the right-hand side of the screen. So again, we are trying to help the engineers with configuring things exactly the same way, but we're also trying to put the flexibility in their hands to handle these special use cases and exceptions. And then I would hit the submit button. It would push out onto the network. The device would be configured. At that point, an automated tool that runs in the background, Rancid, and the populator would then see, oh, a new configuration. There's new configuration on router 3. It would read it in. It would see that it is a new VPN tunnel service, and it would update the database with that information. This is something that happens today. Rancid and populator are continuously scanning the network for new configurations, new services, and then updating what's in the database based on that. So we configure what our intent is. It gets pushed out to the network. Rancid and populator run, looking at the current running state of the network, and then that gets pulled and picked up into the database. Let me stop sharing now. So that's a sort of a basic overview of where we are and where we want to go, along with a little bit of our progress. Any questions I can answer?
Hey, Grover, I just finished typing it, but I can go over it. So I was curious, when you first selected the device, was that showing the current config? Because I'm thinking like the sub interface, right? Without, to ensure you're not overlapping, if it doesn't show what's currently there, you'd have to manually go to the device, right? Which could be acceptable, right? You go to the device, see what's there, make sure you're not overlapping. And then the second part would be, I know that by having the chunks of config, the chance for like a commit error is low with that, right? Because that's all been vetted prior to. But
Right.
does it show a diff before it actually applies?
Oh, yeah.
Okay.
Yeah. So let me answer your second question first. Yes, it does show a diff. In all cases, we're trying, again, to keep the expert artificial intelligence. The artificial intelligence is the engineer's brain, right? These are the people that understand the routing configurations. So we try to do a diff at every step, and we try to make sure that the engineer is the one doing the error checking. The automation is just helping essentially with the standardization. And to answer your first question, Adam, can you help remind me again?
Yeah, sure. So basically, in that example, you're applying like the VPN and then you're making a sub interface, right?
Oh, yes.
Yeah.
Okay, I got it. So you would have to, the question was, you'd have to understand, in the case of the Indiana Gigapop, they increment their sub interfaces by 1 every time. So 45, 46, 47, and so on. So the engineer would have to understand what the last used sub interface number was so they could put in the next sub interface. And so there's really 2 answers to this question. The most immediate answer is it's up to the engineer to know what they need to do. Now we can help because we're using a Yang file. We can say, hey, for the subinterface field, you need to use the next unused subinterface. So we can actually put that as text right above that, or we can include a hyperlink that goes to the database and shows them all of the currently used subinterfaces so the engineer can quickly make a determination of what the next subinterface unit should be. So there's this sort of low effort, which is, or let's say low effort, which is the engineer assisted analysis, where we put in instructions or hyperlinks to help the engineer pick the next subinterface unit. If we wanted to do more work, we can actually put the effort in to automatically determine the last used subinterface and then increment that by 1. In fact, with the Indiana Gigapop's VPN service, I believe there are only 5 of the 8 or 9 fields. Only 5 of them are unique. I think that's the pre-shared key and the customer's remote IP address, which router it goes, no, not even that, which customer it's for. So maybe 3 unique things. Everything else could be intuited or derived from existing information, such as what is the next subinterface in use, or go grab me the next /30 that's not in use so that I can use it as the point-to-point. I could even potentially create a new pre-shared key and send that out. But this would be slightly more effort, right? Somebody has to go into the Yang file and create that model for determining all of the used subinterfaces and what the next one should be. So 2 answers. There's the low-hanging fruit answer, which is we leverage the engineer, but put in hyperlinks and text and other things to help them derive that in a much faster way. And sort of the higher effort methodology of absolutely we can help with these sorts of auto-derived things. We can suggest the thing to the engineer, but it's more work up front. Does that help?
Yeah, for sure. Thank you. I appreciate that.
Okay.
Provo, we've also got a question from Leroy that says, can you talk more about projects and how they may integrate with ticketing?
Sure, I totally can. So we have a lot of flexibility there. The description field, comment field, description field, both in GitHub and in our NAT front end, both of those can be leveraged for a wide variety of purposes. So we can, for example, say, if this is part of a change, then go update the change management ticket with whatever the engineer typed into that description field. We can make that description field required, so the engineer has to type something in. And maybe for an emergency incident in the middle of the night, maybe we have a ticket 911 that always hangs around. So if the engineer puts something into the comment field that says this is for KB 911, emergency fix for customer Earlham College to resolve BGP inconsistencies, that can then be pushed into ticket 911 and then backported later. So we can require these sorts of comments and description fields. We can also make them optional and optionally update any ticketing system that can be remotely, that has an API attached to it. In addition, we can take those changes and if the device allows it, we can push those descriptions or comments into the device configuration directly or into the device management system that the device runs, so that when you look at a history of what was done on the device, show commit, for example, on a Juniper, you would see these comments as well. Does that help with your question, or did I misinterpret it?
No, that was pretty good. But I also was wondering, so how are you forming a project, since the list, you're saying the list of devices is related to the project?
Oh, I see what your question is. Right. So our projects are very flexible. So we could take, for example, on a specific managed network, we can group the devices in that into as many subgroups or as few subgroups as you are interested in. So if you want one big project that has all of your devices in it, we can do that. If you want to group them by, I don't know, manufacturer or core device versus CPE device, backbone device versus CPE device versus closet device, we can do that as well. Does that help? So it's not really, we're not enforcing standards upon the networks. What we are, any specific standard, what we are saying is that you must have a standard, and the standard you define is something that we can work with. So you don't have to do it via method X, but you have to do it somehow.
Okay. So you could possibly use device
Oh,
role.
yeah.
Or,
Oh yeah, absolutely.
okay.
I'm sorry, I cut you off. I do that when I'm excited.
That's fine. It's a little, with the, yeah. So we could basically use parameters in the database that are associated with sets of devices to then form projects. Because sort of where I'm going with this is, sometimes we get like, we do Nessus scans and we get a security incident, and we want to be like, okay, these devices that are part of this, we want to form into a project where we're then do a configuration change and push it out type of thing.
Yeah, absolutely. So I can talk a little bit more about that. We can use role codes in the database. We can use tags in the database. We can intuit the host name. So if routers start with RTR and switches start with SW, it can be based on the host name. We can also create arbitrary lists. So if it's just, these 6 devices, we can organize around sort of an ad hoc arbitrary list as well. So really any sort of arbitrary, we'll say SQL search function, we can think of it like that. Any arbitrary SQL search function, we can organize the projects around. Again, you don't have to do it a certain way, but you have to do it someplace. So,
yeah. All right. Thank you.
Sure. Other questions? Well, if you do have questions, please feel free to contact me or send in a ticket to the NOC and they'll get the question to me. If you're not using our network automation tools yet, contact Corey, and Corey can help us get started down that path with you. Again, our sort of first part is complete. It's done. We have 200,000 lines of code under automation at this point, about 45% of the code base. We can turn you up relatively quickly on these processes. We have additional help to help you get started, so we're not just throwing this over the fence at a group of engineers. There's expertise available. The second part of our project with this sort of intent services-based tool is something that we are deploying right now with our first user, the Indiana Gigapop. And I think they're going to talk about that a little bit in their talk later today, their lightning talk. So we are sort of just working through the beta of that right now. trying to work through the initial issues, but it should be ready to go in just a couple of months. I'm around all day today and all day tomorrow. So if you're having a meeting with GlobalNOC folks and you want to talk automation, just let them know and they can pull me into your breakout meetings.
Awesome. Thank you, Grover, for your presentation.
Thank you.